Hello, your objective in these notes is to understand how to write dissociation equations and to describe how ionic and molecular substances dissolve and to predict whether or not the resulting solutions will be conductive or not. We can write dissociation equations that describe what happens when a soluble ionic compound dissolves in water to form an ionic solution. Here's how to write a dissociation equation for sodium chloride dissolving in water. Sodium chloride is a salt, an ionic salt, so you write NaCl, and then with the small parentheses, write an S there to indicate it's a solid. It completely dissolves. So you're going to show the charge on the resulting ions. They're aqueous. And the chloride ion, which is also aqueous. Potassium permanganate's another ionic compound, but it contains a polyatomic ion. Here's its dissociation equation. Notice that the products are the potassium ion and the permanganate ion, and each have a little AQ subscript next to them to show that they're floating around in the solution. We can write dissociation equations for acids dissolving in water. You can identify an acid, it'll have a hydrogen ion in the front. So here's the dissociation equations for hydrochloric acid and sulfuric acid. Hydrochloric acid all by itself is a gas, but if we dissolve it in water, that hydrogen ion in front will come off, and we'll also get a chloride ion. Sulfuric acid has two hydrogens in the front, and so we'll write two hydrogen ions are produced, and a sulfate ion, and that has a charge of -2. Organic acids are compounds with carbons, hydrogens, and a group called a carboxyl group, that's COOH group. So it consists of neutral molecules as a pure substance, but when they dissolve in water, they dissociate partially to form some ions. That basically means that when you put some acetic acid, for example, in water, not every molecule of acetic acid is going to dissociate. So notice that we have that little equilibrium arrow there. So when we write this dissociation equation, all I'm going to do is take this last hydrogen off. It's the hydrogen that's part of this COOH group. So I'm going to write CH3COO, which will have a negative charge because it's lost a positive ion, and the hydrogen ion, H+. This is the acid that makes up vinegar. When you take a covalently bonded substance, otherwise known as a molecule, and you dissolve it in water, it doesn't come apart and break into ions, so you don't write dissociation equations for those. When iodine dissolves in water, and it does so only very slightly, it does not break up into ions, it simply stays as neutral molecules. So the equation that we would write for iodine dissolving in water would look like this. You simply write the molecule again in full, and you put NaQ beside it. Organic substances, those with carbons, hydrogens, and oxygens in the same formula, form molecular solutions as well, with the exception of organic acids, because those organic acids will lose a proton and form ions in solution. But ethanol and glucose, which are molecular substances, do not. So when you want to write an equation describing them dissolving in water, you just write the formula intact, CH3CH2OH, and you put a little AQ beside it. That's it. Glucose is another example of this. The molecules stay intact, they just separate from one another. When dissolving a substance, the resulting solution will be conductive if the solution contains ions, and we call that solution an electrolyte. So when dissolved, positive and negative ions are removed from a solid in a process called dissociation and are now free to move around. You'll see here a picture of an ionic compound breaking apart into ions, and those ions are now free to move. The positive ions are attracted to a negative electrode, and the negative ions are attracted to a positive electrode. So in this way, ionic solutions definitely conduct current. Anytime you have positive and negative charges that can move, that's a conductive solution. Organic acids will be weak electrolytes. Remember, organic acids produce those positive hydrogen ions in solution. They're weak because not every molecule of acid will break apart. So as long as you're getting ions, you have an electrolyte or a conductive solution. When covalent compounds dissolve in water, they form non-conductive solutions. So when molecules such as glucose or sucrose or ethanol dissolve in water, the molecules don't break into ions. Instead, the molecules just separate from one another and fit between the water molecules. You can see that in this picture here. You don't see any positive or negative charges, so the resulting solution is a non-electrolyte. It's not conductive. So in summary, here's what we've learned. We can have ionic versus molecular solutions. Ionic solutions break into ions or positive and negative charged particles. Molecular solutions do not. We can write dissociation equations for ionic solutions because they break apart to form ions. We have electrolytes versus non-electrolytes. Those are solutions that either conduct electricity or that don't. A solution will be conductive if it has charged particles in it. If it doesn't have charged particles, it's a non-electrolyte. And that's it.